Okay, if you are asked to decide if three sides can make a triangle, I kind of want you to think about it as a bridge. So for instance, if we're looking at the numbers 4, 6, and 12, and we're deciding that if I had these three lengths, could I make a triangle? Well, if we think about the 12, the biggest side, as being like a river, right? So if this side is 12, there's my water. All right, so this side is 12. This 4 and this 6 need to be big enough to make a bridge across this water. Well, what are 4 and 6 added together? If I had a segment that was 4 and a segment that was 6, I would get 10. Is 10 big enough to reach all the way across to the other side? I see a gap right here because 10 isn't bigger than 12. These three sides can't make a triangle because 10 isn't big enough to reach all the way across 12. All right, let's look at another set of numbers. If I had 5, 5, and 8. All right, 8 is my biggest number, which means 8 is going to be my water. So I put that down. And then what is 5 plus 5? Well, 5 plus 5 is 10. So if I stretched that out, 10 is bigger than 8. Is that big enough to reach all the way across the water? Yes, it is, with some left over. So I would say this one would make a triangle because 5 plus 5 is big enough to reach across 8. Now, the one scenario that we need to think about that's a little weird is if we had, let's do 7, 4, and 11. All right, so in this situation, 11 is the biggest, so 11 is going to be the water. What is 7 plus 4? Well, it's exactly 11. If your bridge is exactly as long as the water you're trying to cross, what's going to happen? That bridge is probably going to float away. That bridge is going to be sitting on the water and it's going to be floating. I don't want to drive across that bridge. You probably don't want to drive across that bridge. So this would not make a triangle. And the reason that this doesn't make a triangle is because when you make a triangle, there has to be some lift. That's what makes these angles down here. There has to be some lift of the two shorter sides in order to reach a point up here to make a triangle. If the two short sides are exactly equal to the bottom, they'll be laying flat across the bottom and they won't have any lift in the corners to make a triangle. So that's how you determine if three sides make a triangle. Now, if you're asked, let me get rid of some of these marks. If you're asked like which sides could work or what's the maximum value of a side that could work, let's look at the numbers 7 and 4 again. If two sides of your triangle are 7 and 4 and you want to know the range of the third side, you can find the smallest number that it could be by subtracting. 7 minus 4 is 3. So if you had the numbers 7, 4, and 3, 3 obviously isn't big enough to make a triangle, but anything bigger than 3 would work. So anything bigger than 3 would work. And then you can find the other number by adding them. 7 plus 4 equals 11. Well, we just saw just a second ago that 11 does not work, but anything smaller than 11 works. That looks like I mean bigger, but that's not what I mean. Anything smaller than 11 will work. So you're looking for a number that's between 3 and 11, somewhere in the middle. And you might see that written like this. 3 is less than x is less than 11. What this means is that x needs to be bigger than 3 and x needs to be smaller than 11. So whatever side you have needs to be somewhere between 3 and 11, but not equal to 3 and not equal to 11. All right, let's look at one other type of question you might get asked. You might get asked if a triangle is acute right, or obtuse based on 3 numbers that you're given. So for instance, if you're given the numbers 5, 6, and 8, and you're asked, does this make an acute triangle, a right triangle, or an obtuse triangle? Well, what this is the Pythagorean theorem, but there's some signs changed. The actual Pythagorean theorem is when a squared plus b squared equals c squared. And so if you plug these numbers in for a, b, and c, and you find that they're equal, you will know that you've made a right triangle. But sometimes those numbers won't be equal, and so then you've got to figure out whether it's acute or obtuse. All right, so key thing, when you're plugging these numbers into a squared plus b squared, the only one that matters where it goes, the longest side of your triangle has to be c every single time. All right, so if I plugged these in, I would say 5 squared plus 6 squared is somehow related to, I put a question mark because I don't know if it's equal to, and I'll put my 8 right here for c squared. All right, and then I'm just going to do some math. So 5 squared plus 6 squared is equal to 61. I just typed that into my calculator. And 8 squared, I know, is 64. All right, so if you're looking at these two numbers, 61 and 64, are they equal to each other? Obviously they're not. So if they're not equal, it is not a right triangle. Get rid of that. All right, well, so if they're not equal, one side has to be bigger. Well, 64 is obviously bigger than 61. So in this case, the c squared side, the hypotenuse side, is bigger. And if the hypotenuse side is bigger, your triangle is obtuse. If your legs side, the a squared plus b side, was bigger, then your triangle would be acute.